I like calling it assignment. Of course, that is what it is. You just try your hands on this. Let me take x to be, again, the set of real numbers. And then I take x naught to be negative 2 or negative 3, as the case may be, any real number at all. And we take r to be 1/2. Here we're using the discrete metric, deepen. I want you to compute open ball with center x naught and radius r. Just tell me what it is without computation. You can easily say what it is following this remark. Again, I want you to compute also, so let me take this is 1, and then the second one, I want you to compute the open ball with center now. I take 1/5 and radius 2. So, still with discrete metric. Then, next, I want to know whether you're following my discussion all this while. So I want you to compute open ball with center 1, radius 1. Again, I want you to compute the open ball with center 5, radius -3. I want to know those who are, if you watch the video very well and you understood what is going on. So to do these problems will be a challenging thing. One of the problems is a very funny one. I want you to enjoy yourself with the laughter there. Thank you. Okay. More examples. This time we take x, d to be the set of real numbers together with the usual metric on r, which is the absolute value. We also take x naught, like the first example we took regarding the discrete metric. We take x naught to be 2, and we take r also to be 1/4. Our goal is we want to compute the open ball with center x naught and radius r. Solution. Observe from definition that this ball with center x naught and radius r is the collection of all w in r such that the distance between w and x naught is strictly smaller than r. In this case, who is our d? This is the collection of all w in r such that d of w comma x naught is absolute value of w minus x naught is less than r. And then this is the same as all w in r such that who is x naught? It is 2. Who is r is 1/4. So such that absolute value of w minus 2 is smaller than 1/4. This is again the same as all w in r such that if you remember the properties of absolute value, let me recall that, then we use it here. So if we recall that absolute value of a is less than less than any positive number k if and only if minus k is less than a, and this is less than k. So we're going to apply this a. So our a in this case is w minus 2. So I'm going to write this as all w in r such that minus 1/4 is less than w minus 2, and this is less than 1/4, in keeping with this property of absolute value. Then again, this is the same as all w in r such that I want to make W the subject of this inequality. Therefore, I have to add 2 to all the sides of the inequality. So if I do that, I get 2 minus 1 on 4 is less than W minus 2 plus 2. This is less than 1 on 4 plus 2. From here we get, this is the collection of all W in R such that 2 minus 1 on 4 will give us 7 on 4 less than W, and this is less than 1 on 4 plus 2 will give us 9 on 4. So we have all real numbers that lie between 7 over 4 and 9 over 4. So we can write this precisely as the set of real numbers intersection the open and bounded interval 7 over 4, 9 over 4. Look, this interval is a subset of the set of real numbers. So from set theory, when you intersect two sets, such that one of the sets is a subset of the other one, you get a smaller set. So this intersection is precisely the open and bounded interval 7 over 4, 9 over 4. Hence, we have that, and that says our conclusion is that the ball with center 2 and radius 1 and 4 is precisely the interval 7 over 4, 9 over 4. This is what we have.